Hello, and welcome to today's webinar. My name is Andrew Ruiz, Technology Analyst at Data Conversion Laboratory, and I will be your moderator today. Before we get started, I want to let you know we will allow time at the end of the webinar for Q&A, so please write your questions in the chat area as they come to mind. If we don't have time to answer all, we will make them available on our site. Next slide. For those of you who are not familiar with DCL, we convert and organize content to create electronic documents, populate databases, publish on the web, and basically get it ready for tomorrow's technology. Next slide. DCL services help you refine your document conversion strategy, identify document redundancy, extract metadata, and transform legacy and future documents for real needs, today and in the future. Next slide. We serve a very broad client base. Next slide. Spanning all industries. Today, we are thrilled to introduce David Maddock, VP and Director of Sales and Marketing at Larson Software Technology. David Maddock started his career at Lawntech, Manchester in the United Kingdom as a graduate entrant where he spent 8 years in the company's technical publications department. He founded Visual Sight LLC in 2014 after leaving BAE Systems, a global defense contractor. David has worked in the technical publications industry for over 25 years. Visual Sight was focused on the technical publications market, providing off-the-shelf software and services. David is currently based in Orlando, Florida, working with Larson Software Technology headquarters in Houston, Texas. Now, without further ado, please welcome David.
Thank you, Andrew. Thank you for the kind introduction, and welcome everybody to the webinar. So today I'm going to speak about the two graphics formats, CGM and SVG. So I've just given you an agenda here, obviously the introduction. Thank you to Andrew again. Just give you a very, very short overview of our company, and then we'll get to the slide presentation and do some demos as well. And then we'll summarize and give you an opportunity to ask some questions if you have any, and hopefully answer them. So Larson Software, we're based in Houston, Texas, founded back in 1984, so over 30 years old. And we have been involved with graphic technology in all those years. So we develop software for the graphics industry, but mainly specializing in the aerospace and defense and oil and gas industries. All our software is based on open standards. And we were very keen in the beginning to promote the use of the CGM format. And to do that, we made a piece of software called VisitX Reader freely available. And it is still today available on our website if you want to have view CGM and TIFF files. We've also developed the first HTML5 CGM viewer. For those in the know, really, that means you can view CGM files without a plugin, and we'll talk about that a bit later. We're also a member of the organization CGM Open that really manages the CGM format. So we specialize in the graphics workflow, enabling publications, professionals, engineers, and geologists and geophysicists to really present their data or publish their data for the market. If you want more information on the company, please go to our website, cgmlarson.com. So I want to focus on really three main topics. This is the objective of today's webinar. We'll talk about conversion, compatibility, and compliance, all related to the CGM and SVG formats. So we'll present some lessons that we've learned in our development process and working with customers, the pros and cons of the format, a bit around compatibility, around browsers and viewer support, and interoperability. In other words, exchanging files easily. And then we'll talk at the end about compliance to certain specifications that you might have to comply to in the, say, aerospace defense industries. So that's probably more specifically where compliance comes in. And we'll talk about those specifications briefly Have they changed, and will they change perhaps in the future? So firstly, just to give you some background on the formats themselves. CGM is a 2D graphics format. It's a long history of publishing quality graphics in different environments and in different industries. More specifically, in recent years, the Web CGM profile was developed to deliver specifically vector graphics for the web. SVG, a much newer format, was delivered really only for that purpose, so delivering vector graphics for the web environment. And it was influenced in the early days by some work by different companies like Microsoft and also Adobe, who kind of were the pioneers of vector graphics on the web, other than CGM. So the final decision was based on the SVG would be based on XML. And if you want some more information on that kind of origin, then there's a link down at the bottom there, and the slides will be available through DCL. So all these links should work. So some information about CGM. Computer graphics metafile, 2D open graphics format. It's not owned, it's non-proprietary. It's managed by the CGM Open Foundation, cgmopen.org. It first appeared back in the 1980s, believe it or not, and it was very widely supported in those early days by many graphics-based applications and CAD applications. Today, you don't really see it as much available, and if it is, it's usually like an old filter, probably back to version 1 of when it first came out. It's actually Web CGM is part of the W3C specification, so it's been recommended by that organization and tested by that organization. And it was also adopted, the Web CGM profile, by the S1000D community. Perhaps one of the downsides for CGM was that it always needed a plug-in technology to view the graphics in a web browser. So that only became apparent later on when over security issues with things like ActiveX, the technology behind the plugin, and also having to actually install the viewer on a target computer, which IT departments didn't really care for. So where is CGM used? Which industry sectors? So I've really mentioned them already, but aerospace and defense, automotive, and oil and gas. The third one, probably, depending on the audience today, might not be as relevant perhaps. But so why these industries? So it's open, it's non-proprietary, and there's reliable data exchange. So it should be cross-platform and interoperable. The commonality is that the CGM profiles allows for validation. So a lot of these industries want the file to be valid and consistent. And there's actually specific industry profiles. For aerospace and defense, it is Web CGM. For oil and gas, it's called PIP. And also in automotive, they've kind of adopted the Web CGM profile as well. The beauty of CGM, though, is it can be used for delivery, so actually delivering data to the customer, publishing, so it could go into some publishing software, such as, say, FrameMaker, but also can be used for the display of graphics on the web as well, with that plugin we spoke about. So it can be used in all those different facets. In the oil and gas industry, CGM is really predominantly used for data exchange and also for the display of information relevant to kind of oil wells and exploration. It's not usually something that's then published downstream. It's only used kind of as in the moment, really. It's not really a published format. And it has no real reason to be web delivered or need for any graphical hotspots that you might find in the technical publications world. Some background on SVG, scalable vector graphic. It's XML encoded format, so it's a text encoded. It's again part of W3C, so you can find it on their website, and it's a recommended format. It's managed by the SVG working group. Again, there's a link there. I won't expect you to actually write this down, but you'll get the slides after. But one of the key or the attractive parts of SVG is it's native to the browser, to HTML5. So no plugin technology is required to view the vector graphic in a web environment. So that is probably one of its biggest strengths so far, is that a lot of people see that as a big advantage when trying to get their vector or illustrations visible on a web page. So where is it used? And now that I've actually said that, at the moment I don't really see it being used too much in technical publications, but I think that will change in the future. So doing some market research, we found that it's used widely in GIS applications, geographic information systems, so maps really on the web, but strangely not in Google Maps, which is still using bitmaps. Obviously graphic arts, you see some vector illustrations, but still probably predominantly raster images like PNG or JPEG are used for graphic arts. So vectors are really used where you need something that you have to zoom in on and you don't want to lose the quality. The other area that we found that it's used in is data visualization, so things like data-driven images, animation, dashboards. So I'm just going to click on this link here, and hopefully you're getting that. And you'll see this is an SVG file, but when I move over it, it's got a spreadsheet behind it, so it's actually being data-driven. So the graphic is SVG, but the link is to a spreadsheet that drives the output that you see in the top left. So you could see this is really useful in like the data visualization industry. So as I said, the main reasons for SVG use: native to HTML5, the quality, the scalability of the image, meaning the retention of the definition, and that link to external data. That's a very useful kind of benefit of using SVG as a format on the web. Just some examples now. The data-driven one that I just showed you is on this particular website. They've got other examples there that you can look at. And one of the main GIS vendors is a company called Esri, ESRI, who are an enormous company that are doing GIS software. So you might want to have a look at what they're doing. So the first topic we said at the beginning was conversion. So obviously this is conversion at the moment from, mainly people want to go from CGM to SVG. So data exchange is it's really a crucial component of that graphics production process. So import, you really want to reuse data that already exists, and the quality is important obviously, and you don't want to lose data in that process. Export, usually you're going to publish the data or display the data, and again the same things apply. Quality, and you don't want to lose data when you export the data out or the illustration or graphic out. So keywords are always the consistency, reliability, and the quality of your graphic. So a bit about the SVG, the specification itself, because this is important. It's XML based, so it's text based. SVG 1.1 is the current version. There's the full version and then what they call the tiny version. The tiny one is really a subset of the full specification, and was designed really for phones and tablets where you needed a lighter format really. Version 2 of SVG is due for recommendation by the W3C in August this year. So I've got no update when that actually might happen. So some of our experiences today with the conversion of the file. On the right, just before I begin, is you'll see here we've just done a quick kind of diagram of the SVG full and then the tiny, and then the tech SVG we put in there is what we have discovered is the elements that are required in SVG really for technical illustrations. Though they're the only attributes and elements that we would need usually from the full specification. So only a really small subset you would usually use for technical graphics or technical illustrations. So you can see there's that intersection though, although small, we do need some elements from the full spec. And what we've discovered is you really only can optimize this exporting of the files by looking at real life files. Like some of the test suites are available are really not that challenging. And we've really found some challenges when we're converting, such as file size, images that are embedded in the CGM file, hotspots that might be in the CGM, line styles and fonts. And the other thing we get, the feedback we get is that the display of the SVG doesn't look like what it looks like in a plugin in CGM. And that's obviously a challenge because we're really working with two different formats and technologies. So, but that is the benchmark that we've been working to. And I'll talk about these conversion challenges in a bit more detail as we go on. So the first one was file size. So this is mainly due, you can see there's quite a discrepancy between CGM and SVG on this particular file. The main reason is that, and we'll talk about that on the next page, is that the SVG is a text file. It's text encoded, but every single graphic attribute is coded as well into the file. And CGM has a big advantage that it's a binary file. It's not text encoded, but we only needs to be coded once, so the file size will be much smaller. So I suppose the big takeaway here is if you decide to embark on a data exchange or data conversion task, then you just need to be careful that your file sizes don't get too large. It could impact the delivery of your data. If you're converting thousands of files, then this could stack up in the amount of megabytes it's going to take up. And it also could have impacts on performance. So that's just a word of warning. Some of the other challenges that I mentioned earlier was the embedding of images in the CGM, and then the conversion is that that CGMs usually have like a TIFF file embedded with a group 4 compression, whereas SVG does not support TIFF, only JPEG and PNG. So again, that could be another impact on file sizes. So it's always probably worth testing the file before you go ahead. Hotspots. The good thing about the web CGM profile is it creates or specifies a standard way of writing hotspot information into the file, whereas SVG doesn't really have any way of writing that file or writing that hotspot in a standard way. And really a standard approach is required if you're then going to do linking with other data. So, and we've been trying to do some work with this tech SVG to actually define a way of writing hotspots consistently. Another challenge has been around line styles, where again, WebCGM defines certain line types or line styles. So an SVG again doesn't do that. It's much freer format. So we've had some challenges of mapping those line styles over, but we've been working to try and improve that conversion. Fonts are always a challenge in any data conversion process, and again, WebCGM does recommend certain fonts such as Helvetica, but it is common that sometimes that the fonts don't map correctly. So again, just be wary of doing large conversion jobs if you make sure the font is working or the typeface is working correctly before you embark on a large conversion process. And standardization is certainly our objective, and probably many of you out there as well. As opposed to exporting SVG, we've also been doing some work around importing SVG. So we've experienced various results when importing SVG, because we've been working on our own particular filter. So at the moment, the verdict is not very reliable, so we won't describe SVG as very interoperable, and that's really because there doesn't seem to be a standard way of writing an SVG file even out of one program and then re-importing it into the same program, and it doesn't sometimes work as you would think. The SVG specification is huge, and many elements are not really required for rendering technical illustrations, so we can ignore a very large percentage of them. But one of the attractive areas is that SVG is based on XML, and is structured. So this is, in the future, this is really useful for kind of validating the file through a DTD or schema. So we should be able to really impose rules on that file and how it's written and how it's imported. So the future looks good to actually try and standardize the format, certainly for industries like aerospace and defense, where that will be required. So conversion to SVG. If you're just taking it, if it's a one-way trip, then things are good because you can retain your CGM file. But there can be problems when you import the file. And we've been working on this Tech SVG initiative. We're going to publish the findings of that and also the elements that we support. So we're going to make that open. But we would still say at the moment that SVG is not really suitable as an archive format. In other words, if you have an archive of CGM or another format, don't throw that away. Keep it and just actually export at the moment if you need it for display purposes. So this is some of the work we've been doing around Tech SVG. We want to create a standard method of writing SVG files, which then will help us import those as well. It's this subset of the full specification and tiny specifications. It will help hopefully define a standard method of exporting and importing SVG elements. We're going to socialize that strategy. We're going to publish the elements that we're going to support, and hopefully other industry partners will see this as a good way forward for them, so we can have really an interoperable format for SVG. So I'm just going to do a short demo on conversion, so just to show you some of the process involved. So let's just take you there. Let's just reset this. Okay, so I've got here, there's a set of CGM files here from the S1000D community. These are all CGMs of what they call the S1000D bike. What I'm going to do is convert them all to SVGs. At the moment, the settings part of this, or the output, is we can export them as SVG. We can give them a hotspot ID, which is where we were talking about trying to give a standard way of actually exporting the data out. Before I actually do the conversion, one of the files in here is this particular one, which is the byte with some hotspot information. So this is a CGM file with the hotspot information on the file. It's like a spare parts type illustration. And then I'm going to do the conversion. So it's quite a quick process. So just 39 files on here. So they've all now been converted to SVG. Should see them in the folder that I selected. And this was the same file here, but now an SVG file. So if I double click on it, you can see that here's the bike again, and the hotspot information is preserved. So that's useful if we want now to display this in a web environment. So we have an SVG, no plugin, and all the hotspots have come through from the CGM file. The only downside of this is there's no real control over this other than the browser control. So you'd still have to create an environment where you could have more interactivity with this particular graphic in the SVG world. So you probably need some kind of toolbox. And we'll talk about that probably in a bit more detail later on. The other thing I can do here is that if I just go back to that file, I should be able to open this in Notepad. So you can see that it is an XML file. The SVG file is XML. And if I do a search, I should be able to find the word hotspot. So you can see here how the hotspots have been encoded. So they pretty much try to keep the same way that they're done in the CGM file. So they look consistent. Okay, so let's get back to the slides. The next topic is compatibility. So graphics are kind of in the food chain. They're probably never seen as important as the text, but it's still there's a lot of kind of things you need to think about, complex things, when you're actually distributing those files out. And this could apply to hardware, software, operating systems. So the key word is that we need to have interoperability of that file. So if we open it in one piece of software or one viewer, we want to be able to open it in another one. So it can be easily moved around in different environments. And we'll also quickly look at this in compliance as well. So following the conversion of the file, you're usually going to want to display it, publish it, and edit it. And the impact can be both on the software that you're going to use and the hardware. So displaying graphics on the web, this is the first kind of area we'll speak about. So when viewing CGM graphics on the web, the only thing you had at this point was plugin technology, and you had different viewer choices from different vendors. If there was an issue with that technology, then you could go to that vendor and hopefully find a resolution. However, if you view in SVG, then you're just viewing it in the browser itself. And the problem is with CGM at the moment is that the support for plugins is going away. So you kind of might be forced into this world of no plugins. So how are you going to cope with that? You're going to use CGM or you're going to go to SVG? So certainly Edge is one of the first browsers that won't support plugins anymore. Certainly SVG solves that issue of plugins, but who do you go to if you have a problem with viewing the file? It's obviously not a smallish vendor or a software house that works in your industry. It's more probably going to be Google or Microsoft or Mozilla. So although we've solved one issue, then perhaps we've created another by who do we go to if the SVG doesn't actually display as we would hope it would. So I've got some another short demo here. So we actually, as a company, recognized this was going to be an issue. So as I said in my introduction, we developed a technology where you can view CGM in a web environment without a plugin. So the graphic here, this is viewing it using is in a HTML5. This is Chrome, but it's a CGM file, but there's no plugin. But we can still have the same kind of interactivity that you would expect if it was a plugin. So the benefit of this is you've got the environment created for you, plus you don't need to convert the CGM file. The quality is good. The speed of the rendering is excellent. So you just need to figure out how to actually do this linking between the two. So if I click on 4, you'll see that it highlights the hotspot here. So that's one possibility that you could use to display your graphics in the web environment. The other obviously is one we spoke about in depth, is SVG. Now, as I showed you earlier with the SVG, so this is not very much technical, very technical illustration, but hopefully it gets the message across, is that you're kind of on your own if you want to develop an environment to view SVG files. So as you saw earlier, I was just using the mouse or the control keys to view, zoom in and out. But this time, I've got a little toolbox, so I can actually zoom in on here, and you'll see that it's very kind of good rendering of the image, very sharp. And this small toolbox, I can just move around. But this has just been some project somebody's done on the web. So you're really kind of on your own a bit if you want to use SVG as a display to display your graphics. So I just wanted to show you that it is possible, but you're going to have to put some effort into doing that. Okay, so publishing the graphics. So what do we mean by publishing? So usually it means that it's a traditional kind of book. It might probably more nowadays than a PDF file. And the CGM file is used widely in the publishing environment. So as I said at the beginning, it could be used to publish, deliver, and also display. And usually we'll be part of, certainly in aerospace and automotive, we're part of Arbor Text Editor or Adobe FrameMaker, where you would import that CGM and then print. And also used in standalone publishing engines as well. SVG has founders also have support, certainly in Adobe FrameMaker, you can import an SVG file to be used for publishing purposes, but I don't really know anybody who's doing that at the moment. My best advice, really, retain your CGMs for print purposes. Not that I don't trust the SVG format, but I just don't think it's just proven that process. Editing graphics. Again, you got lots of choices for both CGM and SVG. And the ability to maintain the graphic is obviously crucial if you need to do revisions or do the creation in the first place. CGM is well supported with software, and SVG mainly by mass market software such as Adobe Illustrator and CorelDRAW, but you would still create those perhaps in their native formats and then export to SVG as your final format. But I would say even in those mass market, keep your original. Don't rely on re-importing the SVG, because we've seen issues with that re-import of that file format. So I wouldn't advise. I would advise against really using SVG as that archive, as I mentioned earlier. So I'm just going to go back to the software again here, and again we're working with CGM files. So with this particular file, if I want to add value to this, say I want to add a call out to this graphic, then you can see I can edit it. I'm editing the CGM file, not the SVG. So I'm just going to go around and add, say, some call outs to this. But then I still have this ability to save the file as a CGM file or an SVG. In this case, I'm just going to put it on the desktop and save it. So I can keep this as my original, and then I can go to the desktop and open that file. So just apologies to get rid of these windows. Here's the file I just saved. Here's the hotspots I just created, and this is the SVG in Chrome again. But you notice we don't have the toolbox, but I could still use the web browser tools to zoom in and out. And you'll see the quality is obviously better. If we were zooming in on a raster image, then obviously we'd be pixelating and losing that quality. So finally, the last topic is compliance. And there are a lot of specifications out there. We've been talking about a few of them already, like W3C, that really is specifications for the formats themselves. They kind of govern the formats and kind of recommend them, test them, and so forth. And both WebCGM and SVG are part of that W3C, so you can pretty much trust those formats. And then we have more the industry specifications like S1000D and also ATA. Excuse me, sorry. And ATA. So CGM is specified as part of the S1000D and iSpec 2200 specifications. It's recommended the 2D graphics formats for both those specs. So you can see this as a good thing or a bad thing, but within certain industries, it's good to have files that you can exchange between companies and organizations and trust that they will work in all those different environments. I must apologize if I made you jump with my cough, sorry. So as I said, why do we have them? I think it's one of the reasons is to drive us crazy sometimes because there's so much work involved. But at the end, I think they do provide valuable guidelines. And in graphics, it's not quite as tough as it would be with XML. But there's still an implementation cost involved in both areas. But in graphics, probably not as high as it would be creating the text itself. CGM is really proved to be a reliable format. Although it's old today, it's been around a few years, it's still not lost its use in the industry. And there are millions of CGM graphics in circulation, and I don't really see them as going away anytime soon. So I don't see any major projects all converting away from SVG to SVG. And the best advice really is to continue using CGM as a deliverable file format. And you could also use CGM as a deliverable and SVG as a graphic display option. So finally, complying to the specifications. This is a very short piece because it's really choosing the right format. So if I go to save as and choose CGM, then this is it's quite easy to comply because you've got WebCGM, which we've mentioned already, S1000D 4.1 to the older version of S1000D, the PIP format, oil and gas, which we spoke about, and then the ATA specifications. So this is the benefit of CGM, really, that you can really get compliant files out and actually comply to the specifications there. This is probably the thing at the moment that SVG lacks. It doesn't really have any compliance to any really specification as such. So very difficult to actually deliver the file. I don't think anybody would accept it at the moment. So that's why I'm saying, yeah, export out, but probably you really still need to keep your original. So to summarize, so over the past couple of years, we've been really working hard and made some significant progress in conversion and compatibility and compliance of our conversions of CGM to SVG. And now we're working on the reverse, actually importing SVG and into our software as well, because we feel this is something that will come eventually. We'll always develop the technology that complies to standards, so that is a benefit to the market. And as I just mentioned, our roadmap really shows that we can have a SVG import, and we've already been working on that, and that should be available within the next week or so, where you can import SVG into our products as well. So we'll be pleased to work with any companies or organizations. We actually work with DCL, who obviously do a lot of conversion. And if you have any issues or you want to talk to us about CGM and SVG, then we're pleased to speak to you. So apologies for the slight break in the broadcast, but I'll put you back now to Andrew to see if we have any questions.
Thank you so much, David. That was a very informative webinar, and really appreciate those demos. Thank you so much. All right, so we have a couple questions that have come in. First question, can XML be interfaced with SVG?
That's a good question. Well, SVG is XML, so I'm not quite sure what that means, but SVG is XML encoded. So if you want one XML to talk to another, or an XML database, I would say it's possible, but really SVG is XML itself. So I'm not sure I've answered that. If anybody has questions that I'm not really answering correctly or in full, then please just email Andrew or myself, and we'll try and answer those in more detail.
I apologize. I may have misread the question. Okay. The correction that was made was KML. Can KML be interfaced with SVG? I apologize for messing that question up.
KML. I have not heard of KML. So obviously a lot of abbreviations out there and acronyms. I have not heard of that. So I don't know if that's a I apologize, it's not something I've come across. So I would say please make contact with Andrew. I'm assuming you've got everybody's details, Andrew, that you could make available, and I would try and take that offline.
Yeah, any questions that we won't be able to answer today, we'll definitely be able to answer those fairly soon in the future. Okay, next question that was submitted was, since it is text, can you write a set of business rules around the standards for the SVG format?
I would say you can. You would probably use a schema or a DTD to do that. So it's just an XML file. So if anybody's familiar with that XML for text, they usually have a schema or a DTD that put the rules on there. Impose the rules. So if there were business rules, you could definitely use a schema or a DTD to impose that on the SVG, yes.
All right. Next question, does SVG handle 3D and/or animation?
SVG animation, yes. 3D, no. Both these formats are 2D only. CGM and SVG, both 2D.
All right.
But definitely animation for SVG. That's one of the reasons one of the things it was designed specifically to do.
All right, cool. Next question. Does it make sense to use SVG or CGM for every illustration in a technical document, or strategically for only illustrations that require high fidelity, callouts, and interactions?
I would say if you have interaction, obviously you have to have CGM or SVG. I think it makes sense to have one archive of formats, and once you get into the world of having multiple formats or native formats, is always a dangerous precedent where you save the file in its own proprietary format. Is that you could potentially have some difficulties then getting them out to another format. So I would say I would keep the formats that you have to a minimum. I know my advice on CGM is that even with raster files with scanned images, I would always take them into or embed them as part of the CGM file, and then you don't have two files floating around. That actually you could actually put in one file and then have the same format for raster and vector illustration. And both SVG and CGM support raster and vector in the same file. That's what really makes them different from other formats. Usually it's either vector or raster, very rarely do you find formats that actually support both, and that's one of the advantages of CGM and SVG that they do. So I suppose what I'm saying is that I would recommend that you, even though it might be a lower level illustration, that you would still use one format, probably CGM.
All right, and there was a second part to this question actually. Are there any downsides to mixing CGM or SVG illustrations with raster images?
Not that we've found. I think the main thing that we've discovered is if you're converting from CGM to SVG, is that predominantly, and I mentioned this during the webinar, that the CGM usually has a TIFF file embedded into it. So if you're converting it, then it's going to change it into either a PNG or a JPEG in the SVG file. So I would definitely monitor the out. After you've done the export, you need to monitor the output to see you're getting the same quality that you get in, and also the file size, probably more important, that because the TIFF file within the CGM is compressed, then it's going to uncompress it when it goes to JPEG or to PNG. So that could cause you some issues with file sizes.
All right. So let's wrap up this with one more question that was submitted. Today you've mainly spoken about 2D graphics. Do you see 3D images playing a bigger role in the future in the future documentation?
Yeah, definitely. And I think there's a lot more software out there that enables you to cost effectively create 3D images. And you see you're seeing a big push for, you know, augmented reality and so forth. But on the other hand, I think it'll only be for specific, very specific kind of supporting information for a particular, might be an aircraft or something, where there might be a very complex procedure where you need that extra help, and it will create a benefit in the time that it takes and the safety aspect of it. So I don't see 3D completely, you know, a complete manual in 3D or anything like that, because I think the cost will still be too high, and I don't think there's any real point in doing it at the moment. But in the future, I think there will be more 3D graphics in documentation. But on the other hand, there's still legacy. There's so much legacy information in 2D out there that it's unlikely that somebody's going to convert all that to 3D. So I think we're going to see more of a mixture of both 2D and 3D in probably the same environment, a web environment. So you might see a 2D illustration, and then you might say jump to a 3D of the procedure to remove something, a remove procedure where it's particularly complex. So yeah, I do see 3D out there, and I think it's more cost effective and easier to deliver now than it was before. So the short answer is yes.
All right. Well, thank you so much for your time, David. I really appreciate it. And thank you, everyone, for attending this webinar. So this will conclude today's broadcast. You can access the recorded version from the webinar archives section of our website, www.dclab.com. Also, our next webinar will be Tuesday, June 26th at 1 p.m. Eastern Time. It's titled Creating Profitable Products Based on Difference and Change, presented by Phil Barrett, who is the VP of Sales and Marketing at Delta XML. Have a great day.
Thank you.